So just as a refresher, actually, let me um, pull up this link. It should be in the chat. Just pull this up if you can. Follow along with us. Everything we're going to access, including the notebooks and the coding and the Google Earth Engine editor and everything, should be accessible through this link. And I might have to post some other links for folks. So I'll ask the moderators to help with that. But for the most part, the content is going to be through this. So make sure you have that up. And I'm going to keep moving in here. So as people rejoin us, if they've taken a break, they can catch up. So what we're going to do in the next portion here is we're going to just give I think a good segue into our practical work, is just talking about what some of the steps are to dealing with remote sensing data. And we're going to touch on something that I think most of you are familiar with, but the types of data we're going to be looking at, raster and vector in particular. We're going to give an orientation to Google Earth Engine, especially for those of you who are not familiar. This is an open data platform for satellite data. And we're going to talk about the Python API associated with that, the GMAP Python package that is very useful for accessing it, and working in notebooks and doing some coding and things like that. And I'm going to walk you through each of these steps as we go. Okay, so first, just as a recap, obviously, again, some great level of detail from Dr. Bao about the work that goes into taking the data from the satellite and the instruments themselves, obviously orthorectifying them, georeferencing them, obviously transforming them based on data around the path of the satellite, the orbit. All that stuff is done. Most people who are looking at this data, including you or me, do not have to do those transformations, thankfully. That has been done, and the data is formatted to some degree. This format, as we'll dig into a little bit, can be complex. So it's good to understand the metadata involved. Obviously, things like the masks, the different bands. Kim mentioned sort of cloud coverage. That's a band. It's a critical one. Those are all things that are a part of these formatted data files. And then additional steps are usually needed. And so that's kind of where we're going to get into today. So things rounding this turn here, so to speak, on the right into the bottom layer, we are going to look at compositing, mosaicing, how you put these images together to form a scene, what further, and many of these composites are available as products already, of course, as you may be familiar. But then you may have to do some additional pre-processing. All right, maybe you're creating zonal statistics. Maybe you're looking at, for specific regions, a time series, that sort of thing. We're gonna get into all of that. And obviously, ultimately, you want to do some kind of analysis on it. You're trying to answer questions or understand what's going on, and visualize and communicate this. And of course, as any of you know who've been doing this sort of stuff, it's very interactive, kind of a circular process. So again, I think the idea is learning these tools to do this. And just as a recap, and I think this is a very helpful segue from what Kim was mentioning, take the time, if you're looking at this data, to think through what you're actually trying to answer. And the reason I think it's helpful for more people to have access to these tools and these data is that it's one thing to build a machine learning model, and I've done that for the past several years. You don't throw those together very quickly. It takes time. You have to build the data pipeline. They're usually very finicky about the data you're using, and you optimize them. This is a really time-consuming effort. You're not going to launch into that unless you have a pretty good sense of what data you're looking at and do some exploration. And so these are the kind of tools that I think are very useful for that. On the other side of the spectrum, you might just be an analyst or someone who's looking at trying to answer some questions. I won't say basic, but maybe they're more straightforward. So depending on what you're looking at, that will help form your analysis and the choices you make about what data you use. What is the resolution that's available? For economic literature, there might be established data sources that people are more comfortable with. Perhaps that's going to weigh into your decision. And obviously, decisions about its availability and sustainability. Kim mentioned something that I think is really, really important. And this is actually something that can be subtle for folks. How to do with things like missing data. So as she mentioned, in the Nighttime Lights product, there are certain, especially in certain months in equatorial regions, cloud coverage that covers the entire month. So you're not able to adequately capture nighttime lights. So what is usually done is that is masked, or it's given a zero value. And as she mentioned, that doesn't necessarily mean that there's no radiance there. It just means that the data quality was so poor. If you're working with this data, you should understand how that happens and what's done. And in most data sources and metadata, you can see that. you may make choices to interpolate data yourself. I wouldn't recommend doing that for cloud coverage because you're talking about a massive swath of pixels. Interpolation will be probably a bad idea across such a large area. But if you have something small that you're masking like gas flares or just bad pixels, perhaps some kind of interpolation is a good idea. So you want to think about these things. So I don't want to spend too much time on that because I want to get into the practical aspects of it, but these are important things to think about. So I'm opening this link in the slides, but you can access this through the tutorial. So if you have the tutorial link open and you're at the welcome page, what I'm looking at is module 2.1 here. And this is just the data overview. I'm not gonna spend 10 minutes on just a couple minutes on this. And we're gonna talk about raster and vector files. And we're gonna come back to this a few times because this is an important concept. Raster files are, I would say, by far and away the most common, and I'm not sure that I've encountered any satellite data that are not in raster files. And you can think of these like you would an image, a photograph. They're pixels, they're cells. Think of it as a matrix. We'll talk about that later. But it's a grid-like data structure. And each grid then represents values of data. Now, you can have multiple values for multiple bands, in which case you'd have a three-dimensional tensor, basically. You have row, column, you have width, height, you have lat, long, however you want to think about it in 2 dimensions. And then your third dimension is the bands or the levels of data. So this is a very common data type, and you can picture it as pixels in an image like this. The other common data type of geospatial data are vector files. And these are basically data that are represented essentially by formula, mathematical formula that represent points and lines. So if you look at these 2 graphs here, they kind of show, I think, a good example of the difference. Points mathematically are dimensionless, of course. They can be infinitesimal. You can have a lat long that it's infinitely precise. In that sense, it occupies no point in space. It's just a location. And so that is an advantage for doing very complicated shapes. But with a raster file, your minimum data point will only ever be as small as the pixel itself. So as you can imagine, you might have a lat long that's so precise, it could get as close to a dime on the ground. But if what you're trying to get is the value of nighttime lights for that dime, the only value you can access is whatever that whole pixel value is, which would cover, in the case of VIIRS data, 742 meters by 742 meters. This is kind of an obvious thing, I think, for folks, but it's really important to understand this because we're going to be doing a lot of operations on these data where you're extracting data from a raster file, but you're going to be applying it to data that might be in a vector file, like a shape file or a geometry, like you would for a country boundary or some arbitrary polygon. So a vector file, you can, obviously a line is just a slope. You're calculating the distance between 2 points in your 2-dimensional plane. And an area is just a little bit more complicated combination of lines. This is sort of high school mathematics here, but you can see how the differences here, particularly the difference between, if you look at the rightmost column here, you see that the vector file shows a polygon that's kind of an awkward kidney bean shape sort of thing there. Perhaps that's an island or some geographical boundary. And then you have the sort of approximate representation of that area in a raster file. And as you can see, the shapes are somewhat different. And what's most important is hopefully you can figure out the resolution of your raster file matters a lot here in this situation. So if you're taking data from the raster and you're applying it to some polygon shape, this is something you have to understand and deal with. And as we'll get to later in this workshop, if you're not careful with how you're doing this and how you're documenting it, you can get vastly different answers for things like sum of lights. And I flag that just not as a warning, but just as maybe a warning, but let's pay attention to how these data are represented because if you're doing analysis and passing things along, it can make a big effect. So I'm not going to go into too much detail about other data structures, but GeoTIFFs are a common format, a very common format for raster files. And they provide a lot of metadata, and there's sort of standards for GeoTIFFs so that metadata like the coordinate reference system, the resolution, how many bands or layers, what's the spatial extent, like what's the overall coverage of this file. These are all obviously critical things to know. And as we'll see from accessing these files in Google Earth Engine or elsewhere, often these metadata are attached to the file directly. And usually they even contain metadata on the satellite's orbit itself, or the time that the data were collected down to the second or millisecond. So there's a lot of information there, and GeoTIFFs just provide a way to package it. Cloud optimized GeoTIFFs, which we're not going to get into today, but we will with later tutorials, are a great concept because they allow you to query parts of a giant file, a GeoTIFF, without having to download or access the entire file. So if you're looking for a particular area, for example, you can do calculations with the cog much more efficiently. Kim mentioned this, but I want to reiterate that we we will soon launch, we meaning the consortium of University of Michigan, the World Bank, New Light Technologies, NOAA, and Kim's a critical part of that, as is Ron, and Trevor Monroe is on the call too from the World Bank, his team. We're going to be putting this data archive out. It's going to be available in AWS. It's going to have tons of information. Here are some of the components that are going to be available there. There's a lot more that you can do with this data. You can make your own composites. You can do your own analysis. We will have nightly data available for DMSP and nightly data available for VIIRS. So you can access those quote unquote analysis ready data, meaning that we've done the pre-processing so that you can take a look at it. You'll still need to think about the data and do things that we're going to talk about later today. But I just want to give a teaser that this is something that we're going to have ready. Today, I'm going to focus on accessing data that's currently publicly available, i.e. through Google Earth Engine. And that's why we're emphasizing the Google Earth Engine platform. It is a great tool for that. It's not the only tool, but it is definitely something that I think will help us sort of conceptually understand how to access this data and use it. So that's sort of the choice today. Yeah, I think just as Ron mentioned in the chat, please note that these are still in development. There may be some subtle changes, but hopefully you'll be able to follow through everything okay. Okay, so let me back out of this for a second. That's just a brief overview of raster and vector data. We'll revisit that later. Google Earth Engine, if you're not familiar, is a good platform for accessing satellite data. Obviously, you can do fun things like time series analysis, time lapse. Forgive me, time lapse. If you go to the link there, you can see a bunch of different time lapse videos that folks have made. Hopefully after today, you'll have a basic sense of how you can make these yourself. They're fun visually, analytically. They don't provide a ton of value in my mind because you want to quantify things, but they're pretty fun to look at. Google Earth Engine is a cloud-based platform, which means that the data is hosted on the Google infrastructure. There is a lot you can do, as we will find, with the data without having to download it to your computer. That's a huge advantage, of course. These are massive files, gigabytes per file in some cases. There are restrictions to that, and I would emphasize this. Think of data as a physical object. In many ways it is, right? It lives somewhere. This data we're looking at lives on a server or probably multiple servers somewhere in the Google ecosystem. We are passing instructions to those servers in order to do calculations, in order to do things with that data. And in some cases, we're telling it, hey, send us a little bit of this data to our screen so we can plot it or make a map with it. I know this sounds simple, but it is important to understand that because sometimes you'll want to do something with these files and there'll be restrictions because in order to do that, you'll have to move the file itself, the data itself to your computer. You may or may not want to do that. But as long as things are cloud-based, there's a lot you can do with the file staying on some other computer somewhere. And so we're learning how to interact with that. And I think it's helpful to kind of keep that in mind. I'm going to just scan through Google Earth Engine. If you haven't looked at it, and perhaps someone can place this link in the chat. It's just earthengine.google.com. And you don't need an account just to look at the data here, obviously. But it has a pretty big data catalog. There are tons of different data sets. If we actually look at viewing, let's take a look at VIIRS data, for example. You can see that we have VIIRS data available, including monthly composites and what are the stray light corrected nighttime composites. So here's a critical thing as you're exploring data. If nothing else, understand the data that you're looking at. We won't always have the advantage of one of the scientists who actually created the data with us, but there is a lot of information out there, and the reference papers and technical papers behind these data are often available. And you can see basic things like, okay, what are the bands involved? What's the unit that's involved in this? These are great reference points for the data that you might be looking at and exploring. Obviously, feel free to go ahead and go explore. And obviously, we're focusing on nighttime lights today, but there's a lot of different types of data out there. And Google Earth Engine, if nothing else, is a catalog of these data and these products in various states of tiers of availability and processing. So that's obviously that I think one big advantage of Google Earth Engine. Another one that I think some of you might be familiar with is just the let me go back to my screen, the editor, which can actually allow you to manipulate images. One thing I'm going to take just a moment here to say, data structure is important. So we keep mentioning the word images. Images are basically how we would describe, a single scene, or you think of it as the raster file itself. You could consider an image, and it may have multiple bands. So when you think of it in the Google Earth Engine ecosystem here, the data structure of a single file is an image, if it's a raster file. And if you have a bunch of them, you have a collection. So you have an image collection. So we're going to use those terms a lot. So for example, you might be looking at an image collection of Landsat 8 data, excuse me, and that collection is going to have a bunch of different images in it that are representing not only different time periods, but also different areas geographically, depending on your satellite data. And then each image itself is going to have multiple bands, in this case, 12 bands. So it's helpful to think about that. And again, as Kim walked through, we're looking at the electromagnetic spectrum for satellite data. And the slices of the spectrum that are stored in bands are, again, usually stated in the description. But these are bands, and it's important that you know this. If you're working with these data, you're going to have to select the band that you want to calculate or visualize. And it could be multiple bands. But this is sort of the layers of data. And obviously for us, I think red, green, and blue are pretty clear examples of visual data. The nighttime lights data, we're working with a panchromatic, so they're just one band that represents light luminosity across a range of wavelengths. So we don't have separate channels there yet, although I understand from Dr. Elvidge that that's forthcoming, which I'm excited about. One thing to note here, and I even said it, we say red, green, blue, RGB, it just kind of rolls off the tongue as a convention that I think goes back to perhaps when television monitors were created. I'm not sure where it started, to be honest, but the order of bands as red, green, and blue, the order of channels is a very common one, and Earth Engine is set up that way as well. If you were to load a file into Earth Engine and visualize 3 channels of data, it's going to pick the first 3 channels. And it's going to assume that the first one's red, the second one's green and blue. Now you can choose the colors you want, obviously, but if it does it automatically, that's what's going to happen. Why is that important? Well, if we think about the math here, the natural science of it, that's a different order because blue is actually a shorter wavelength, green is longer, and then red is still longer. Now, that makes a lot of sense to me in terms of organizing it. But if you were to just throw the file into your map without changing the order of the bands, you might get a weird colored image because you have to make that change. I'll come back to how to do that kind of stuff. I want to point that out just so we know that's something to kind of think about. Okay, so I mentioned the Google Code Editor. So here is where, if you have an account, you can click on this link and you can follow along with me in the editor. If you do not have an account, I think you're going to be limited. You might be able to view it, but you're going to be limited in your functionality. You probably won't be able to access the editor that we're going to look at, in which case, bear with us and just kind of follow along with me here, and we'll get to some other work later. I'm not going to spend too much time with the editor because there's a lot of good stuff here, and there is a lot of documentation on it. But I am going to spend time with the functions in the Python API that are very similar to this. So I think it helps to get an understanding of it. So if you open the editor, and that link is code.earthengine.google.com, you will see something like this screen. You'll have a map area below, and depending on your internet bandwidth, it might take a little bit to load. On the left panel, you have your assets, your scripts that you have saved. You have documentation. So you can actually go directly to something here and say, okay, well, we talked about images earlier. Well, what is that? Oh, an image I can see. oh, it's an object that represents an Earth Engine image. There's a number of arguments there. So if I want to construct an image, I can use that. And then there's a lot of methods that belong to the image, so to speak. So the idea of having methods or functions that are attached to a data object is an important concept. We'll come back to that. But it basically says, okay, I have an image and I want to, I don't know, I want to add something to it. I want to convert it to something. There's a method that will help you do that. And we'll get into that, but I'm just orienting you to this documentation. And in the center here, you have a panel for your actual script when you're writing, and this is in JavaScript. This Earth editor is a JavaScript editor. If you know JavaScript, great. If you don't, you can pick up the syntax, but that's something there. And then the console will print up data. So, and then below you have a map to visualize. So I'm just going to show a very quick example here. And again, if you're following along, great. If you're able to open the editor and able to look at this, then you can kind of play along with what you're doing. If not, then it's okay for now, because I'm just trying to get you to understand the concepts really about what these files and these data structures are like and how you can access and manipulate them. So let's start with something fairly simple. So we have a JavaScript here that is going to be pulling some data, in this case, Landsat 8 data. And if I were to just pull all of this data, what I'm doing is I'm referencing the location. And if you want to know where the location is, I mean, this is Google after all, you just Google it in their search engine, and I can say, okay, well, what's the data set? Oh, I want this data set. Oh, here it is. This is the information. I can copy the snippet, and then that's what this is. If I paste it, basically I'm getting, some variable that points me to an image collection. So this is a bunch of images. How many images is it? Let's find out. So we're saving this as a variable. This is a concept we'll deal with in this workshop. You're taking some operation and you're saving the results as something that you can access later. There is a method called size that is attached to an image collection. And what that does is it tells you the count of images in that collection. That's all that we're doing. So what we're going to do here is run the script, and we're going to access this image collection. We're going to save it as a variable, and then we're going to print out in our console what the size is of this collection. And you can see in my console here to the right, it's computing. Now, this isn't happening on my laptop. This is happening on a Google server. It's taking a moment. That means that this is probably a pretty large collection. Just how large, we'll find out in a moment. And as you can see, I've commented out some of the other ways to filter an image collection, and that's going to be important for us because here we have our answer. Okay, over 1 million images. There are more than 1 million images in this particular collection. That is a lot. There are a lot of years of data here, and don't forget, for each day, each year, there may be multiple passes per day in some cases, in some images. And these images, especially the Landsat images, you're going to have multiple images that cover the surface of the Earth. So one particular image will only be in one particular area. So obviously working with over 1 million images is not practical for most reasons. So you're going to usually need to filter this. And let's say, all right, I'm just looking at I just want to filter for the images that fall between January 1st and December 31st of 2019. Okay, we've narrowed it down, 150,000 images, which is still a lot. One of the other things you can do, and we'll cover this again in more detail. I'm just going through these concepts right now. Don't worry if it's going quickly. We will get into this more. But if you want to use some of the tagged data sets that Google has, one of them is this geospatial data set that has boundaries for different administrative units, including countries. So here we're actually looking at level 1, which for those of you familiar, administrative level 1 is a state or province level. And we're looking for a province or state named New York. We're not very specific here, so it could be any state in the world named New York. There just happens to be only one in this data set, and it's the one that I'm currently in. So what we can do now that we've got this is a feature collection. It's analogous to an image collection. It's a bunch of objects. And this variable in New York is saving only the objects that are named New York. So that is really just one. So we're getting a one object, and you can actually display that. The map variable will create an object and you can center it on that geometry we just created, and you can display it. So New York is the name of the geometry we're displaying. We're not doing anything with the visual parameters yet, and then we're going to give this layer a name, New York. So, and I'll comment out the size. So now when we plot, and I didn't change the colors, so we get the sort of black color here, but now you see we have New York as a geometry on our map. And so what do we want to do? Like, if we filter to New York, this is a comment. If you've used Google Earth Engine, I've had a few folks who have had this question. When you filter on New York, all you're doing is you're saying, okay, of this collection of 150,000 images, I only want the images that intersect with this geometry of New York. I'm not clipping my data to that yet. I'm just saying, of all of these images, only give me the ones that touch New York. And so you can see that the number of those images is a much smaller number. And that's because we're obviously dealing with a smaller area. For time's sake, I'm not going to get into the details of sort of selecting bands and doing the mosaicing, but I think it's important to kind of realize that once you get a sense of what images are and what image collection is, you should be able to, and this filtering is taking a bit of time. Okay, so 326 images that span the time of 2019 and span the space of touching New York are in this collection. And so you can see how filtering kind of helps you narrow things down. I could even go as far as to say, I only want the first image. But now what's happening is instead of an image collection, I'm getting just a single image object. And when I do that, what I can actually do is I can print out information on this object. And this might be helpful for you if you're looking for metadata. So this might take a few moments when it's filtering. But okay, so you can see in my panel here, we have the image collection name. We even have the name of the particular image that we're looking at. This happens to be the first image. We see that there are 12 bands. You can even go in and you can see, you have the coordinate reference system. You have the dimensions of data that are in that band. If you go to properties, you can see metadata that are associated with this, including the cloud coverage for that band in that particular time period, the Earth-Sun distance, the ellipsoid that we're using is WGS84, and so on and so forth. So there's a massive amount of data that's available here in the file itself, okay? So that's kind of helpful to know that this file itself has all this metadata in it. Okay, so this is just a brief example. I just wanted to show you some of the things related to these images. We're going to move on and look at some other things. We'll come back to these concepts, including how to actually layer and visualize these things. But I just want to, it can be intimidating to look at code like this if you haven't done it before. And I just want to say, if you just kind of break things down and see what each line is doing, and hopefully it's intuitive, it'll help you kind of understand what you're working with. Okay, so let me go back to this slide deck. Okay, I just showed you one example. I'm not going to go through the other one. It's sort of doing some similar things. But I just wanted to orient folks. If you're not familiar with Google Earth Engine, that is what it's capable of. You have a data catalog with a ton of data in there, including nighttime lights, composites. And then you have an editor that you can use to do things like visualizing data, manipulating, transforming images. You can create zonal statistics. You can do a lot of things there. There is a decent amount of documentation on the JavaScript functions for the Google Earth Editor. There are not as much documentation for Python API work, which is why I'm going to walk through some of that today, but they're very similar. These methods are essentially exactly the same. They're named the same. They do the same things, but it's helpful to kind of get oriented. Okay. Key technologies that we're going to talk about today. Python is a statistical programming language. I'm sure many of you have heard of it. Many of you might actually have worked with it. It's an open source language, and there are a lot of libraries associated with that. And we're going to look at a couple, including the Earth Engine API library and a library called GMAP, among others. We're going to be working with Jupyter Notebooks, and we're going to also be working with Colab Notebooks in Google. These are basically interactive platforms for you to do code work in them. We'll get into some details on that in a bit. If you haven't heard of Python or know anything about it, it's a very popular language for data science and for analysts because of a lot of reasons. It's open source and it has a very large library For example, GMAP, what we're going to look at, our research scientist decided that he wanted to write that package so that it could help work with Google Earth Engine, and he just submitted it, and it's now open to the world, and anyone can contribute to it. That happens quite frequently, and so he's saved a lot of work that you would have to do manually. That is a huge advantage of open source languages like this. And not only that these libraries are available, that people are actively supporting them and adding to them. It's a general purpose language. And I think that's another point I want to make so for me, and perhaps for you, I'm often working across many different data types. So you might be doing some sort of analysis where you're integrating census data or survey data, data taken from other sources. Perhaps you're pulling that from a SQL database. Perhaps it's a CSV file. You might be manipulating this data using Python. You can do that all in one script or one place, one set of scripts, one pipeline. And you might also want to query satellite data, and using the Python API, you can do that. And you don't have to go to the software platform, download it, save it to your computer, do some work with it. And then you could do that all through just the same set of Python scripts. And for simple data pipelines, this is really helpful. For more complicated data pipelines, especially when you're integrating things or doing modeling, this is really, really a useful aspect of Python. And it's one of the reasons I've decided to focus the tutorials on this, because I think it helps open a lot of other things. So if you are, I don't want to say brave, because I don't think it's that big of a deal, to be honest with you. But if you're following along and you want to work through this code directly live on your computer, I want to tell you how to do that here. And we're going to spend the next probably 5 to 10 minutes to close out this section, just showing you how to set these tools up, so that as we work into the next segments, you can actually work through this code yourself. Again, if you don't have the setup, that's okay. You can work through this content as well. So if you don't have Python on your machine, and chances are you do, but one of the things you can do, and you should be able to see my terminal here, is you can just type Python in, and an interpreter should show up like this. That means you have Python on your machine, you're accessing it. You can even go further as to say, all right, what version of Python do I have? Well, I have Python 3.8.2. There is a library, and I referenced this in the tutorial. So just so you guys know, this is in the tutorial module 2.2. And it has a lot of resources for Python. If you're not, this isn't a Python workshop, so we're not going to spend too much time trying to understand the language. But if you want to dig into this more, there are links and resources. Again, this is an open community, so open data, open source community, so there is a lot of information out there. There are a lot of ways to install Python. One way to do it is through a package called PyEnv. Now, if you have a Mac or a Linux machine, what you can do is, let me minimize that. What you can do is use a package manager called Homebrew, and you might have it installed already. And with that, you can install this package PyEnv. If not, there is a link to do that, and I should be up here somewhere. I might have to make this link live, but PyEnv is, oh, here we go. This I guess the link isn't live, unfortunately, but this is the link for installing it for Windows, and this is the link for installing PyEnv if you have a Mac machine. Now, if you have Homebrew, you can just type in brew install PyEnv, and I'm not going to do that because it's going to take a few moments. But if you do that, you will install this package. What is the advantage of a package like PyEnv? Well, you can install multiple versions of Python, and that might be necessary for different projects. I'm, again, not going to get into the weeds on that. That's too much for this overall workshop. But believe me when I tell you, if you're going to be working with Python and you're going to have multiple projects, probably you will, you're going to want to be able to set up environments, virtual environments, to use Python in different ways. And it makes it really useful and handy. So if I have PyEnv installed, and I know I have PyEnv installed because when I go which Python, which tells me which Python am I using, what comes up is Python, let me deactivate my, sorry, which Python, what comes up is Python that's listed in the directory called PyEnv. So I know that I have it on my machine. And now what I'm going to do is I created a directory called ONL. That's what you see here on my computer. There's a couple files in it. I'm going to remove those. There's a couple files of it. in this directory, and I'm going to make a virtual environment, and I can do that with the venv module. And again, this is all covered in the tutorial. So again, please don't worry if you're having trouble kind of, my intent is not for you to do this live. I don't think that's a good use of time. But I do want to show you that if you have this stuff set up, what you can do is create a virtual environment for your project. And now I activate it by saying source venv, which is the location, and I activate my file. There are a lot of different ways to set up virtual environments. This is just one. But now that I've done this, now when I say which Python, I see that, okay, the Python that it's listing is the one that's right in this package. I know this all probably sounds like gibberish to many of you. That's okay. And the reason I did this is now I can install different libraries. So I just mentioned that one of the advantages of Python is you can have access to a whole bunch of libraries. One of those libraries is called GMAP. And pip is the Python index package module that allows you to install things. So if you have Python installed, you have pip installed. And with pip, you can now install other packages. Let's install Jupyter. It should already be installed here, but I'll show you that's as much as we have to do. And when you write pip install Jupyter, now I have the Jupyter package, which allows me to open notebooks. We'll get into the notebooks in a little bit, but I just wanted to spend a few moments here to show you if you're working on your laptop and you have Python, I would suggest using PyEnv. You don't need to, but I suggest using it because you can install different versions of Python there. And then as I just showed you, you can create a virtual environment. You can see these parentheses here. That indicates to me that I'm within my virtual environment. Anything I download in terms of Python packages is only for this environment. If I have another project somewhere else, I can install other libraries there. But this allows me to do this. And one of the things that makes this more useful is I can actually launch a Jupyter Notebook. So if you're looking at my screen now, you can see Jupyter Notebook allows a browser interface. And I launched Jupyter Notebook, and it's loading whatever's in this directory, which is right now really nothing, just this venv directory that has a lot of Python stuff in it that we don't need to worry about. In a later today, I'm going to show you how actually downloading notebooks can go right into this. Actually, why don't I do that right now? Just show you quickly. This page you're looking at on this website here is actually itself a notebook. Right now this isn't live code. Okay, these aren't actually things you can execute. But this is a notebook, and if I were to download this, which you can see here, there's an icon. I can download it as a PDF. We're all familiar with that format. Or I can actually download it as a notebook file. And you can't see what's happening now, but basically you know how to download files from your browser, hopefully. What I've done is I've downloaded this file and I've saved it to that directory I just created. And now when I open up my Jupyter Notebook, you can see that file is now in there. And I can just open it with a click like that and there. So if you have Python at home and you don't need an environment set up, but I've suggested, but if you have Python at home and you have Jupyter installed, using this website, you can just download a file like this and you can open up a notebook just like we did here. And this makes it, I think, pretty simple. And so now, from now on, if I'm ever accessing, let's say we'll get to image clipping here in a bit. Okay, here's an image clipping notebook. This is all code. These are some cool maps we'll create. I can download this, and it's as easy as just, okay, I just downloaded it into that folder. And now when I open up my Jupyter Notebook, here it is. And here's that clip, or here's that notebook on clipping. Now, the other way you can access things today is, let's say you don't have Python or you don't want to worry about doing that on your laptop. That's okay. You don't need to. What I've done is create links to Colab notebooks, and you can see a little button here. Most pages, let's go back to the page we were at, getting started with, actually, no, that doesn't happen, sorry. Here we go. Here's an exercise. If you were to go to module 2.6, and we're going to open this up as soon as we come back into the next section here in a few minutes. This is a notebook on how we can actually visualize images using Google Earth Engine. Just like any notebook, you can download it locally on your computer, or if you go to this link, you can open this as a separate notebook. This is the exact same notebook. Some of the images won't render. That's okay. And we'll talk about functionality is a little bit limited in Colab. That's okay too. But essentially, you now have a notebook just like I ran, but now you don't have to worry about installing anything on your laptop. The advantage here, of course, is you can do this from anywhere in the world. You have internet access and a Google account. However, there are limitations, and it does take a little bit longer to do some things, and some things are limited. So, for example, I was just installing libraries earlier, like GMAP and other libraries on my laptop. I only need to do that once. However, if you're opening Colab notebooks like this, every time you open a new session, you're going to have to install a library. So we'll get into this in the next section. Yes, I want to run this. But if I were to try to run this code, it's going to give me an error. And the error it's going to tell me is, hey, there's no module named GMAP. That doesn't exist. And so the reason that doesn't exist is I have to actually install it. So if you're using these notebooks, I've included the line of code to install these. And that's what's happening right now in the background. What's happening is this is on a Google server somewhere. It's installing this library for me. And now that it's done, it's telling me, okay, restart your session. And I click this button and restart it. That erases all my current variables, but that's okay. I haven't created any. Now I can comment that out just to keep things clean. And when I run it, it does nothing. And you comment things out in Python by adding this pound sign. Now that I've done that, now I'm ready to run this code, and it will not throw that error because GMAP is installed. But what it will do, and this is again, if you have an account, this is where you can authorize it, is say you need to authorize this this account so that you can use Earth Engine. So you click on this link, and if you have a Google account, you pick the Google account associated with Earth Engine. For me, it's my personal account. And I allow it, and it gives me a code snippet. Don't worry, there's no security risk. This is a one-time only code that only works for me. And you hit enter, and there I've authorized. So now I don't need to do that again for this notebook. So if you have an Earth Engine account, by clicking on the link just as I did, you should be able to go through the steps that I just did. And if you do so, you can now actually display a map. So this is, in fact, a map pulled from Google Earth Engine, and I'm showing it here. It is interactive. I can zoom in, I can move it around. We're going to do some more stuff with maps later, but essentially this is one of the things GMAP is really useful for, helping you create these interactive maps. So just to kind of recap briefly, we showed the Google Earth Engine editor before. And because that's useful if you're actually working in the editor, what we can also do are much of the same functionality, but this time in a Python notebook. And as you can see, we've just displayed a map just exactly for that. I'm not going to, the only other thing I wanted to get through in this section was just working through some examples of using notebooks, including the Python API. We're going to get into that in the next section. It's okay when we start doing some exercises. I'm going to, obviously we're recording this video and we'll share this. We'll also share the resources here, the links to these examples. And by the way, if you got the email prep for this workshop, these are the links to those notebooks. So you've already gotten these links. But I just want to orient you to these again. You can spend some time kind of playing around with notebooks. Here, I'll open another one. This is just a generic Google Colab notebook. It tells you what they are. There's a video if you want to look at it. This is actually code that I'm running live here. And what are the seconds in the day? Well, that's the formula 24 by 60 by 60. There's my answer. So you can see that this is actually helping to run code. Here's something a little bit more complicated. I'm making an actual plot, and so on and so forth. So this is the advantage of notebooks, is you can mix sort of text and plots and code. And so if you're not familiar, it's a useful thing. So we're going to, again, take a few minutes break so we can get back on track here. In that time, I'm going to be around to help answer some questions. I apologize. We have so many folks. It's kind of hard to do something really interactive. But again, I would just keep deferring to that original link to the tutorial. Everything that I've showed you so far is accessible here, and going and looking at these links. And if you want, just to help for the next section, maybe spend a few minutes trying to, whereas the Get Started with Python, trying to just see if you can load it on your computer if you'd like, or if you just don't want to mess with that right now, that is totally okay. Just know that every time we go to a notebook, there's going to be this little button to open in Colab up here in the top left. Click on that link and follow along with us in a notebook. And we're going to do that as we get into some of the actual exercises here after the break. So that's it for this section.